Lesson 38, Simplifying Expressions Using GCF. GCF, I hope that you all remember, is greatest common factor. So, for example 1, all it's wanting us to do is to find the prime factorization of each number. So, I'm going to start with 180, and I'm going to use a factor tree to help me find the prime factorization. So, whenever we use a factor tree, remember that we're splitting the number into two numbers that multiply to get that number. So because this ends in a 0, I'm going to start with 18.
Upon the interruption of the line, students need to report to working lunch with Mrs. Shoup at this time. Zach Peterson, Aaron Riddle, and Albert Hernandez. Thank you.
I'm going to start with 18 and 10 because 18 times 10 gets me 180. So 18 is not a prime, so I'm going to split it. Two numbers that I know that multiply to get 18 are 6 and 3. And 6 is not a prime, so 6 will be 2 times 3. 2 is a prime, so I circle that one. 3 is a prime, so I'll circle that one. This 3 is a prime. And then I have 10, which is not a prime, and 2 times 5 gets me 10. 2 is a prime, and 5 is a prime. So the prime factorization of 180 is 2 times 2 times 3 times 3 times 5. You could also write that as 2 to the second times 3 to the second times 5. Both of those are equally acceptable in my book. I want you to go ahead and do B on your own paper, please. GCF, or the greatest common factor, to find the GCF, or greatest common factor, okay, it says finding the largest monomial that divides without a remainder into each term of a polynomial. So, what we have on example 2 is it says find the greatest common factor of each expression. So I need to know what I can divide into each term on A evenly without having a remainder. Now the way that we do this is we start with the coefficient part, or the number part of each term. And I have 9 and I have 12. So I need to know what will divide into both of those numbers evenly. Well, the only numbers that divide into 9 evenly are 1, 3, and 9. I hope that you already know that. For 12, we have a significant amount more because I have 1, 2, 3, 4, 6, and 12. 6 and 12, sorry. I thought I skipped one there. So of those, the greatest is 3. 3 will divide into both 9 and 12 evenly, and it's the largest number that will without having a remainder. So I'm going to have 3. Then I have a to the 4th and a to the 2nd. Well, we know that a to the 4th is a times a times a times a, 4 times, and a to the 2nd is a times a, which is 2 times, and the greatest common factor is going to be a to the 2nd because I can take a times a out of both of those. But I cannot take a times 4, not a times 4, a to the 4th out of both of those. Because this one, as we said, was a times a times a times a. And this one is just a times a. Well, I can take a times a and a times a, but I still have this 2a left here, which means, or a times a left here, which means that I couldn't have taken that from this. I hope that you can see that. This a times a will come out of both. So I'm going to have a to the 2nd, and then I have b to the 7th and b to the 5th. So this would be b times itself 7 times, b times itself 5 times, and the greatest common factor is going to be that b times itself 5 times, so b to the 5th. Now a good rule of thumb for finding the greatest common factor when you're dealing with variables and exponents is that the smallest one available is probably what you're always, is always what you're going to take, okay, because I can't take 4 out of 2, I can't take 7 out of 5, okay, so I have to have enough available. Now, on B, I have 4 and 6, those are my coefficient parts that I'm going to start with, And 4 is divisible by 1, 2, and 4. 6 is divisible by 1, 2, 3, and 6. So the biggest number that I can divide into both of those evenly is a 2. And I want you to find what the variable parts of this is going to be with the exponents. So pause at this time and figure out what the rest of the greatest common factor is here. So I have m to the third and m to the second. I said earlier we want to take the smallest exponent, so I'm going to take m to the second because I can take 2 from 3, but I can't take 3 from 2 without getting a negative. I have n to the fourth and n to the sixth. The smallest one there is n to the fourth, so that's what I'm going to take. And p to the sixth and p to the fourth, which means I'm going to take the smaller one, which is p to the fourth. Final answer. This is my greatest common factor of this right here. So it says to factor each polynomial completely. We're going to factor using the greatest common factor. So I have 3 terms here, 1, 2, and 3. What can I divide out of each of these evenly? Well, looking at the coefficients, I have 9, 3, and 1. Because I have a 1 there, I'm not going to be able to divide 3 into 1 or 9 into 1. So my greatest common coefficient factor is going to be 1. But I still have variable parts. I have x to the fourth, x to the second, and x. So the smallest is going to be this x because it's understood to the first power. So when I factor these out, what you have to remember is that I'm dividing. It's very important for you to remember that you're dividing. So because I brought this x outside of my parentheses, I'm dividing each of these by x. Okay? Because that's what's coming out. I'm sorry, those look like monkey symbols there. Okay, but they're x's. I'm dividing them on each term because that's my greatest common factor. So if I have a 1 here, because that was the greatest coefficient I could have. I don't have to show that though. So in my first term I have 9. X to the fourth divided by x. I hope that you remember that this is the first and I'm going to bring it up and subtract it. So that would give me x to the third. My sign stays the same because this is a positive, so it's a negative still. And I'm going to have 3. X to the second divided by x gives me x to the first, or just x, plus x divided by x is, those cancel, but they cancel to a 1, so I have to show that term. This is my final answer, completely factored. Okay? On the next one, I'm going to do the exact same thing. I'm going to start by finding my greatest common factor. So between 8 and 6, my greatest common factor is a 2. X to the fifth and x to the second, I have x to the second, so I'm going to take the smaller exponent. Y to the third and y to the eighth, again, I'm going to take the smaller exponent, so I have y to the third. Then I have 8 divided by 2, because I'm dividing this whole thing, remember, by my greatest common factor. So I have 2x squared y to the third, and on this one I'm doing the exact same thing, 2x squared y to the third. Alright, so 8 divided by 2 is 4. X to the fifth over x to the second gives me x to the third. Y to the third over y to the third, that cancels, which is a 1, but I don't need to show times 1 here, so I'm just going to leave it as being gone. Minus, because my sign isn't changing, 6 divided by 2 is 3. X to the second over x to the second cancels. I don't need to show times 1 though. Y to the 8th and over y to the 3rd will give me y to the 5th. And this again is my final answer. On this one, it wants me to simplify each expression. This is very similar to whenever we are getting things into slope-intercept form, or when we're solving for a variable and we're dividing on both sides. We talk about that. Well, this is dividing this entire thing by 4, which means that the 4 goes to each term in that numerator. So 4x divided by 4 would just give me, that's an equal sign, pretend it looked like one, x, plus 8 divided by 4 is 2. And if you don't remember that, remember we can always write it as 4x over 4 plus 8 over 4 because we, oops, I just put the answer. 8 over 4 because we know that it goes to both. So the 4's would cancel, which is what happened. We're left with x, plus 8 divided by 4 gave us that 2. Same thing happens here. Okay, this 6ab goes to both terms. So I'm going to start by writing it as 6a over 6ab minus 36a squared over 6ab. So my 6 and my a cancels, which means I'm left with a 1 on top over b minus 6 and 36 reduced to a 6, so I have a 6 on top. So I'm going to write that on top. A to the second over a. Remember, this is to the first, so I'm going to bring it up and subtract 1. So I have a, and my b is still on the bottom, so I leave it as b. Okay. Now I have a common denominator, so I can rewrite this as one fraction, which is 1 minus 6a all over b, my final answer. Last example here. I have the formula h equals negative 16t squared plus 76t plus 16 can be used to represent the height of an object that is launched into the air from 16 feet off the ground with an initial velocity of 76 feet per second. Rewrite the equation by factoring the right side using the greatest common factor and making the t squared term positive. So I'm going to start by rewriting the right side because that's all it wants me to work with. It says rewrite the equation by factoring the right side. So the right side is the right side of the equal sign, which is all of this right here. So I have negative 16t squared plus 76t plus, 16. Now the first thing it wants me to do, the first thing that it wants me to do is it wants me to make that t squared term positive. Well, the t squared is right here, this term. It wants me to make it positive, which means to make it positive, I'm going to have to divide out a negative. So I'm going to have negative, and then I have to have something that will divide into each of them evenly, and that is going to be 4. Okay, so it's going to be 4, and I can't take a t because I don't have a t in this last term. So I'm going to have negative 4, and negative 16 divided by negative 4 is 4, and that t squared stays exactly like it is, plus 76 divided by 4 is going to give me 19 t, because again I'm not dividing by t, so it's still there, plus 4. And this is my final answer. So that's all I have for you today. Please make sure that you've taken good notes, and I will see you in class tomorrow. Have a good night.